appears to be working. Okay. So, without a calculator, I would like you to divide out this problem. So I'm going to ask you to think way back, almost a decade ago, back when you learned how to divide into, or divide numbers. Okay? And so this number is the dividend, and this number is the divisor. Okay, so the divisor goes on the outside, and then we have this funky little division symbol, and then this number goes inside. And then we look and we see, okay, how many times does 84 go into 9? And the answer is none, so we skip over that one. Then we look and we see how many times does 84 go into 91, and that's 1 time. So then we do 1 times 84, and we put that there, and that's going to be 84. And then we subtract, and that gives us 7. And then we bring down the 7. And then we say, well, how many times does 84 go into 77? And the answer there is 0. So then we would do 0 times 84, and we put it there. And then again, we'd subtract, and we'd have 77. And then we would bring down the 8. And we would say, well, how many times does 84 go into 778? And so we would probably say there that that would be 9. And then we would do 9 times 84, and we put it there. And so 9 times 84, come on, come back to me. 9 times 84, we might have to go off to the side, and we might have to do 84 times 9. Well, that's going to be 36. Carry the 3 is going to be 72 plus 3 is 75. So this is 756. And then again, we would subtract, and that's going to be what, 22? And then we bring down the 9. And then we'd say, how many times does 84 go into 229? And that is 2. And so then we do 2 times 84, and that's 168. Oops, wrong color. And then we'd subtract, and we'd get 161. Okay. And so then our answer here would be 1,092 and 61/84. Or we would say 1,092 with a remainder of 61. Would be the answers that we would go with there. And just a quick check, 91,789 divided by 84 gets me 1,092.72619. If I did on a calculator, which that would be what that fraction would be. Love it. Okay? Questions, comments, concerns, clarifications on long division? Okay, is that remembering some things? Things coming back to you a little bit here? Okay, because what we're going to be doing today is we are going to be dividing out polynomials. And we are specifically today going to focus in on long division. of that. And so we're going to do that exact same concept of what we just did. We are going to do today, but with polynomials. And that's going to be what we're going to use today is we're going to use polynomials. So what it's going to look like is it's going to look like this. We're going to divide using long division. Okay? Love it? Okay? So again, same setup as we just had. Okay? The dividend, right there. The divisor, or if you wanted to say divisor and divisee, I'm fine with that. I mean, I really don't care about those two terms. Okay? But what comes after the division symbol is what goes on the outside. Let's see. 3x cubed plus 17x squared plus 21x minus 11. You're going to need some space for these particular problems, okay? Because we're going to line everything up vertically. Okay? So now what you do is now you look at first terms. Okay? So I want this x right here to multiply by something and get me 3x squared. Well, x times 3x, oops, I think I said 3x squared. I meant 3x cubed. Okay? X times 3x squared is going to get me 3x cubed. Okay? So now, just like before, I'm going to take 3x squared, and I'm going to multiply it by x plus 3. And I'm going to write that right there. Okay? So that's going to become 3x cubed plus 9x squared. And then I've got to subtract that. But tap the brakes, because we have to, in order to subtract that whole polynomial, I'm going to subtract both parts. I've got to change the signs, if you will, on both of those terms. Okay? So now, 3x cubed minus 3x cubed makes that term go away. And that's what we wanted. We wanted that first term to be eliminated. 17x squared minus 9x squared would leave me with 8x squared. Now, I drop down the next term, just like we did when we were dividing numbers. We drop it like it's hot. Drop it like it's hot. Okay. So we've got that. And now, again here, I would want to make this x become 8x squared. And so I'm going to do that by multiplying it by 8x. If I multiply 8x times x plus 3 and put it right there, I would get 8x squared plus 24x. Subtracting, I'm going to change both of my signs. 8x squared minus 8x squared makes that one go away. 21x plus negative 24x is negative 3x. Then I drop the negative 11. Now I need x to look like negative 3x. So I'm going to multiply that by negative 3. Negative 3 times the quantity x plus 3 is going to be negative 3x minus 9. Change both of my signs because I am subtracting. Negative 3x plus 3x makes that go away. Leaves me with negative 2 as a remainder. Okay? So the answer to this particular division statement here would be 3x squared plus 8x minus 3. And now you could say remainder of negative 2, okay, r negative 2. I would accept that, okay? But the true, actually your tablet breaks. Let me put this in a different spot. We'll put this down a little bit farther, because then I can show you the differences. Okay? So we would have 3x squared plus 8x minus 3, remainder of negative 2 would be okay. But my preferred method would be 3x squared plus 8x minus 3 plus, and then the fraction of negative 2 over x plus 3. Okay. The second method there, the second way I have it written, that is the preferred mathematical method because it gives it to you in a polynomial form. Okay. Questions, comments, concerns, clarifications. Either you can put them in the chat or unmute yourself. I know that this stuff is somewhat confusing because we got a lot of moving parts going on. I will tell you that in years past, I found that aligning things vertically. So if you'll notice here, let me get a highlighter here. If you notice, all of my x squared terms are aligned vertically. All of my x terms are aligned vertically. Everything's lined up vertically, and then that way you have everything. It's kind of a way to organize your work so that you know what terms should be there. You shouldn't have any x squareds out of the x squared column. Okay? With that being said, let's go on to the next one. Okay? I will set this one up for you, and then I would like you to do it. Okay? This problem has a tweak to it, a twist to it. Okay? Because this problem is really x cubed plus 0x squared minus 4x plus 6 divided by x plus 3. Okay? We need to have that placeholder. We call this a placeholder when we are doing division. We can't just skip over that term. We have to write all of our things in standard form with placeholders. Okay? So that when we get going then on this, now that we can, whoops-a-daisy. So now that when we're going on this, now when we go to set it up, now it would be x plus 3 divided by, or dividing into x cubed plus 0x squared minus 4x, then plus 6. Okay. What I would like you to do now is I would like you to complete this particular problem, and then we'll go through it. I need x to look like x cubed, so that's going to be x squared. So I take x squared and I multiply it by x plus 3, and that's going to be x cubed plus 3x squared. Then I change my signs. And that gets rid of the x cubed, and it makes negative 3x squared right there. Then I drop the next term. Now I want x to look like negative 3x squared, so that is going to be negative 3x. Negative 3x times x plus 3 would be negative 3x squared plus, minus 9x. Change my signs, plus and plus there, gets me positive 5x. There. Drop the 6. I need x to look like 5x, so that's going to be plus 5 there. So then we're going to have 5 times x plus 3, and that's going to be 5x plus 15, and then I'm going to switch both signs, and that's going to be negative 9 there. So my answer here would be x squared minus 3x plus 5 plus negative 9 over x plus 3. Thumbs up. You got that? Side? Maybe missed 1 or 2 signs? Down? Got no clue what we're talking about. Good, good, good. Lots of thumbs up on that. Okay? The reason that we have to teach you long division is because of a problem like this. Synthetic division, which we will learn next week, Monday, when we come back. Synthetic division, don't get me wrong, yes, synthetic division, much easier, much quicker, much smoother, easier, faster. I'll be able to explain synthetic division to you in like 3 minutes. Okay? It's just that quick and that easy. I get that. I love doing synthetic division too because of the ease, because of the simpleness. However, synthetic division doesn't allow me to do a problem like this. Okay? This problem needs to be done, or can only be done, I should say, utilizing long division. So we set it up very much the same. Okay? So x squared minus x minus 2 goes on my outside. On my inside goes x cubed plus 3x squared plus 0x, because I got to have that placeholder right there, minus 7. Okay. So the setup is the same. We got to make sure that what's inside the dividing sign has every term or every exponent from the biggest one all the way down to a constant at the very end. Okay? And then when we go to actually do the problem, we do it the same way. I want x squared to look like x cubed. Well, that means I need to multiply by x. So here is going to be x times now x squared minus x minus 2. So that's going to be x cubed minus x squared minus, oops, I got to go over a little bit more, minus x squared minus 2x. And now instead of changing both signs, I change all 3 signs for my subtraction. The x cubes go away. 3x squared plus x squared is going to be 4x squared. 0x plus 2x is going to be 2x. And then I drop down my negative 7. Again, now I look for what is going to make x squared become 4x squared, and that would be multiplying it by positive 4. So that would be 4x squared minus 4x minus 8. There. Change all 3 signs. First one goes away. 6x plus 1 is what we're left with. So my answer here would be x plus 4 plus the fraction 6x plus 1 over x cubed plus 3x. Oops, tap the brakes. I went the wrong one. I was looking at the wrong one. Over x squared minus x minus 2. Huh? Try that one on your own. Just do a quick spot check here just to make sure that you got it all set up the way that it should be before you get too far involved with it. Maybe. There it goes. So we should have x plus 3 here divided by 2x to the 4th plus 0x cubed minus 13x squared plus 0x minus 45. Okay. So we should be sitting at that right now, or you should actually be well past that by now. But then we would want to go here, so this would be 2x cubed is going to be 2x to the 4th plus 6x cubed. Change and change gets me negative 6x cubed. Bring down the negative 13x squared. So that's going to be negative 6x squared. So that would be negative 6x squared minus 18x squared. Change and change. 5x squared. Drop down the 0x. So that would be plus 5x. That would be 5x squared plus 15x. Change and change gets me negative 15x. Drop down the negative 45. That's going to be negative 15. Negative 15x minus 45. Change and change. 0 gets me 0 there. So we got nothing left over. That's cool. Okay? That means that it evenly divides in because there's no remainder. It's kind of like 8 divided by 2. It's a remainder of nothing. Okay? So the answer here then would just be 2x cubed minus 6x squared plus 5x minus 15. We like these kinds because later on in this chapter, later next week, we're going to say, we're going to solve this, okay? And we know then that x plus 3 is a factor because it evenly divides in. That means that negative 3 is a 0. That means that we can then do grouping on the 2x cubed minus 6x squared plus 5x minus 15 to find the other 3 zeros. Okay? So we can find and find and find, and we can keep factoring to find more things. Love it. Okay? Thumbs on this one. Up, we got it. Side, we missed a negative. Usually, the biggest spot that you're going to make a mistake is like you're going to miss changing that second term's sign. Okay? The sign. But otherwise, everybody else pretty good. Love it. Okay? So, the question of the day. I didn't type it out today, but that's okay. What's your favorite? Breakfast, lunch, or dinner? That's the question of the day. And going forward now, the rest of this week, there is a week 8, I believe we're in now, week 8 worksheet that is posted up there. It is 2 problems. It's 2 long division problems because that's the only thing we've got going on this week. So it's 2 long division problems. It's posted on It's Learning. You can get that done as soon as you want. You can turn that in at any point in time. I would recommend doing it right now and turning it in yet today and all that fun stuff. Okay, so you can do that. And then starting tomorrow at 8 o'clock, 8 a.m., the quiz for this week, and it's a summative quiz this week, will open, and you need to have both of those accomplished by Sunday night, November 1st. Okay? That's all I got for you. Have yourselves a great, grand, and wonderful week, because I won't see you now until next week, Monday at this time. And hopefully, and actually at that point in time, we'll see some of you back here in class. So, all right, so we'll see you later.